Hey everyone, welcome to the part 2 video of Fast ML course. Now that we are building a good foundation, it's time to talk about something super important in machine learning, trust. How do you know if your model is actually good? How do you avoid building a model that works perfectly on training data but that fails miserably in the real world? That's where cross validation comes in. In this video, we'll break down what cross validation really means, why it's like a reality check for your model, and how it helps you build models that are not just smart but reliable. We'll keep it super simple with real world analogies, walk through easy examples, and finally show how you can apply cross validation in your projects. Ready to make your own models? Not just smart but strong. Let's dive into cross validation. So, the problem that we are facing so far is we have simply been told which points are the training data and which points are the testing data. But however, usually no one tells what is for training and what is for testing. So, how do you pick the points which are for training and the best points for testing? So, the solution for this is when you're not told which data should be used for training and for testing, we can use cross validation to figure out which is which in an unbiased way. Rather than worry too much about the specific points which are best for training and best for testing, cross validation uses all the points for both in an iterative way, meaning that we use them in steps. So imagine we gather imagine this to be our axis and six pairs of weight and height measurements. Weight and height, and six pairs of let's see these one, two, these are the six pairs of weight and height measurements, and because we see a trend that people with taller heights tend to be taller, larger weights tend to be taller, but we want to use weight to predict the height. So we decide to fit a line to the data with linear regression, which is simply what we have learned in the previous class. So, however, we don't know which points to use for training and which to use for testing. A terrible idea would be to use all these points for training and then reuse the exact same data for testing. Because the only way to determine if a machine learning method has been overfit to the training data is to try it on new data that it hasn't seen before. So, reusing the same data for training and testing is called as data leakage and is usually results in you believing that machine learning method will perform better than it does because it is overfit. Okay, and a slightly so that is considered as a terrible idea. A slightly better idea is to randomly select some data points to use only for testing and some for training. Now let's considering these random points to be for training and these points to be for testing. And this avoids data leakage. But how do we know we selected the best data for testing? So, there cross validation enters and solves the problem of not knowing which points are the best for testing by using them all in an iterative way. So, in the first step, these points are used as test training and these for testing, and in the second round there will be a different part, so these will be used as These will be used for testing and the rest others for training. And in the round 3, it uses a different set or the never used data for testing and the rest all for training. So these two are used in round 3, these two are used in round 2, and these two are used in round 1, right? So randomly assigning the data to a different groups. So in this example, we divide the data into 3 groups where each group consists of 2 data points. Now in the first cross-validation iteration, we'll use this group 1 and 2 for training. So these two groups are for training and the rest is considered for testing. So in that way we can, you know, consider the errors between the predictions and then validate the model. So because we have done this or divided the data into 3 groups, and we'll be doing 3 iterations, which ensures that each group is used for testing. The number of iterations are also called as folds, right? And so this is called as 3-fold cross validation. So these are the 3 iterations of training. Because each iteration uses different combination of data for training, each iteration results in a slightly different fitted line, and the rest lines are used for testing. Okay, now solves the problem of not, so here this cross validation solves the problem of not knowing which points to test by iteratively using all of them. Okay, and when we have a lot of data, we use 10-fold cross validation, which is most commonly used cross validation when in large data sets. So to perform 10-fold cross validation, we first randomize the order of data and then divide the randomized data into 10 equal sized blocks. Then we train using the first 9 blocks and test the 10th block. Okay, and another commonly used form of cross validation is called leave one out validation. This uses all but one point for training. So it leaves out one point for testing and the rest all are considered as the training data, and then iterates until every single point has been used for testing. Okay, so some experts say that when the dataset is large, use the 10-fold cross validation, and when the dataset is very small, use the leave one out cross validation. So that's about, cross validation. And the conclusion or the summary in this chapter is, when you use cross validation to compare the machine learning models, sometimes the black line will perform better and sometimes the green one. When the results are mixed, how do you decide which method is better? So for that, we need to involve statistics. One way to answer this kind of mixed results is, how do we decide which method is better, or how do you evaluate the model or the data points, or how do you divide the training and testing data appropriately for the model to perform better? So here statistics is used, and that's what we'll talk about in the next chapter. Thank you.